Hello everyone, welcome back to our SPSS instruction series. Today we are going to talk about how to run an ANOVA in SPSS. Again, if you are having an issue with analysis or if you want to have more clarity on your dissertation methodology, feel free to contact us. The contact information is below in the descriptions. So we are now looking at a data set that is just a sample data set with 20 participants. And this is the data set for professors and their income, basically their income. So we can see the first column, it says academic ranking. So we have 1, 2, and 3. If you want to know what they mean, you can go to the variable view. I've introduced this to you before in another video. So if you look at academic ranking, the values are 1 assistant professor, 2 associate professor, and 3 professor. So we want to compare, let's go back to the data view. We want to compare the academic ranking and their salary. So if we want to see if there is a difference in terms of salary between the 3 academic rankings. All right, to do so, we need to go to our favorite tab, that's Analyze. Okay, and compare means. So we click one-way ANOVA. All right, so for our dependent list, for SPSS, you can actually name multiple dependent lists. So if we want to talk about salary, sure. Or we can talk about the years of PhD since the graduation. But today we're only going to talk about salary. So we are going to put salary over, and then academic ranking as factor. So in SPSS, it calls the independent variable factor in ANOVA. All right, let's see. Since we have 3 groups of academic ranking, we are going to run a post hoc because we want to be able to tell, okay, which one's the highest, which one's the middle, which one's the lowest. So click post hoc. And usually we just run an LSD or an HSD or 2-key. That's what it says, 2-key here. Okay, and you don't have to run them both. They're pretty similar, but I'll show you that they are similar. Continue and options. We want to see descriptive statistics and the homogeneity variance. It is important for some research to see if you achieved homogeneity variance, because if not, then you're going to have to do adjustments. So with that being said, a useful thing after you click the homogeneity test, you also want the Welch test, because if there is a violation of homogeneity, you want to look at the Welch results instead. All right, and the next one, it says means plot. It is a visual kind of summary of what your post hoc is going to be like. So if group 1 is higher than group 2, the graph's going to show you that, but it won't necessarily show you the significance. So you can tell there is a difference in terms of the graph, but for you to be sure if it's significant, you would have to look at the post hoc, the 2-key test. Just click that for now, continue, and we're okay to go. So click OK. And there we have it. So first of all, we see the descriptives. The descriptive statistics is going to tell you how many, which is the N, how many people are in each group. So we have 7 assistant professors, 6 associate, and 7 professors. And that's their mean income, that's their mean salary, and standard deviation, and so on and so forth. So excuse me, the next test is going to be the homogeneity test that I mentioned earlier. And here we actually don't want to see a significant. Right now, the significance score indicates that the test is significant, which is bad, because if you think about the hypothesis for the homogeneity, so the null hypothesis is going to be the variances are equal. And the alternative hypothesis is going to say the variances aren't equal. So if we are to reject the null hypothesis, then we have to say, okay, the variances aren't equal, which is our case. So we are not looking at the actual ANOVA test, because that's not valid anymore, because there is a violation of the equal variance assumption, the homogeneity variance assumption. So instead, we're looking at the Welch test, which is the one following the standard ANOVA. It says robust test for equality of means. So we achieved significance. There are adjustments done for the degrees of freedom. So degrees of freedom for between groups is 2, but for within groups is actually 10.076 instead of 17. So there was adjustment done for the degrees of freedom. But regardless, the significance level is it's still good. So we can conclude that there is at least a pair of the 3 academic rankings that are different. So to be sure which ones are different, we have to go to the post hoc. So here we have the Tukey and the Tukey HSD and the LSD. And you can see the numbers are very similar, if not exactly the same. So to read this, you are comparing assistant professor to these 2. So I minus J, that's what it says here, the mean difference. And if you see an asterisk by the I minus J number, then that means there is a significant difference between those 2 groups. For example, I'm comparing assistant professor to associate professor in terms of their salaries, and their mean difference is negative 15, and that's significant. What does that mean? It means to use the mean salary of assistant professor, subtract that by the mean income of associate professor, you get a negative number, which means associate professor makes more than an assistant professor in this case. And the same thing goes to full professors. It's negative 36, and it's also significant. So professors make much more than assistant professors. So, so the only thing that was not included in the previous pairs was the associate versus professor. And then, so if you compare those, the difference is negative 21. So professor, tenure professors would also make significantly more than associate professors. And so if you look at LSD, it's not exactly the same, but they're similar. The results, I would say, the outcome, 99% of the time, the outcome are the same in terms of significance. All right, so switch to the means plot, and that's the one that I said you could look at it visually, but you can't really determine which one is higher or lower than the other one, or if that's significant. You can only tell if it's higher or lower, but you can't tell if it's significant, and that's what it is. It shows you where the mean is for each, and then it gives you a visual effect. So this is really good if you're writing up a chapter 4 and you want some type of visual, you want some type of figure to summarize your conclusion. So that would be something that you can include in your dissertation, either in the main body or in the appendix. Okay, there we have it. So we have a very simple analysis of variance, which is ANOVA, And again, if you have any questions, feel free to give us a call or visit our website.